All right, we need to talk about interpreting a regression output table because this is basically a silver platter. They're giving you everything that you would need to be able to answer about a question on a silver platter, but it looks like just this jumbled mess of numbers and words. And so you need to know what all the jumbled mess of numbers and words mean, okay? So I want to talk about the most important ones that we're dealing with right now, which are, first and foremost, are the slope, the y-intercept, and we'll talk about standard deviation and where you can find the correlation coefficient, okay? Couple of these are vocab words that are coming up soon, but I don't mind previewing them a little bit, okay? So if you think about like a line, like y equals mx plus b, or what we have is y hat equals a plus bx, okay? Which one is constant, okay? And if you studied pre-calc and even algebra, this is called the linear term, and this is called the constant term because there's no variable on it. And so when I look at the constant here, the constant is going to be the y-intercept. Oh, I'm making a white line. Let's change that color. The constant is going to be the y-intercept. So the coefficient is the number in front of the variable. I know that there's no variable here, but it's kind of like the last coefficient, the constant coefficient. The y-intercept is always your constant coefficient when you're in standard form. The income tells me first and foremost that this is my x variable. Okay, that's my x variable is income. This is cost versus income. Usually it's y versus x. All right, we're measuring y as x changes. All right, so this is my x, and we're going to write my mx plus b, or my a plus bx, all right? But this must be my slope, okay? So this is, can income predict pet expenses is really what this is. So this is the cost of having a pet versus income. And annually, your y-intercept is 438.53. So we can say pet costs are predicted to be $438.53 plus 0.511 times our income. Okay, and maybe the income is measured in thousands because I doubt that it would be per dollar you make. 51 cents of it is going to be spent on your pet because that would be crazy. Okay, no one would have pets. All right, but now you notice this. This is like my a plus b x. Okay, so you can see a plus b times x, income. The x is always right next to the slope, just like here. The x is right next to the slope. The x is right next to the slope, and the y-intercept is constant. Okay, this is something we'll get to later. Okay, the standard error is literally the standard deviation divided by the square root of n. The standard deviation divided by the square root of n, and there's a t-score associated with it, and a p-value is the probability that either of these are zero, and there's pretty much zero probability of that being the case, and we'll get to that when we get to inference for regression lines at the very end of the year. The other two things that we're going to be working with are this standard deviation. Okay, this is the standard deviation of the residuals. So it's how far points are away from the line on average. So not away from the mean, it's away from their predicted value. So there's an idea of a residual, which I'll talk about in the next video, but how far away are you on average from the line? So instead of average distance from the mean, it's the average distance from the line. And we'll talk more about that standard deviation of the residuals, okay, in the next section. All right, but I don't mind previewing it, okay? So we never use this r squared adjusted, never, never, never. So I'm crossing it off for you, okay? We use what's called r squared. And the cool thing about it is if I want to know what r is, it's literally the square root of r squared. But I need to make my r squared as a decimal. It's always written as a percent. So in this case, my r would be the square root of 0.91, which comes out to square root 0.91 equals 0.954, okay? So that's pretty strong correlation here, but we can see that it comes from r squared. This r squared has an interpretation that we'll talk about. It's called the coefficient of determination, which sounds awesome. And there will be a video exclusively devoted to interpreting r squared. Okay, but we can get our correlation coefficient. We can get our slope and our y-intercept. Slope, y-intercept. The y-intercept is the constant, and we can get our standard deviation of our residuals. Everything you need, and even this stuff will be useful to us later. So powerful if you know what you're looking at. And so learning the y-intercept is the constant, the slope is always attached to your x variable, your standard deviation or your residuals, and use r squared, not the adjusted one. All right, so good luck. We'll see you soon.